Something impossible just happened. Again. For decades, astronomers believed that objects from other star systems would almost never cross into our own. The distances are too vast, the odds too small, the timing too cruel. And yet, here we are. A new object has entered the solar system, moving far too fast, following a path that makes no sense for anything born around our sun. Its arrival wasn't announced with a flash or a warning. It slipped in quietly, detected as a faint moving dot against a crowded background of stars. But the moment scientists calculated its trajectory, the room went silent. This was not a visitor from the Kuiper Belt, not a long-period comet returning from the Oort cloud. This object came from somewhere else entirely, beyond the heliosphere, beyond the influence of the sun, out of interstellar space. In 2017, Oumuamua shocked the world by becoming the first confirmed interstellar object ever observed. In 2019, comet Borisov followed, proving that Oumuamua was not a fluke. But since then, astronomers had begun to relax. Years passed, nothing arrived. Until now. In mid-2025, a routine sky survey detected something that immediately raised alarms. The Atlas telescope network, designed to spot fast-moving objects before they can threaten Earth, recorded an unfamiliar trajectory coming from the direction of the galactic plane. At first, it was just another designation in a database, another automated detection among thousands. But when older images were pulled from archives, something unsettling emerged. This object had been hiding in plain sight for weeks, maybe longer, moving so fast and from such a crowded region of the sky that other surveys had missed it entirely. When its orbit was calculated, there was no doubt. The curve was extreme. The eccentricity was off the charts. This object was not gravitationally bound to the sun. It was not staying. It was passing through. Astronomers gave it a new name, 3I Atlas, the third interstellar object ever confirmed. But unlike its predecessors, this one refused to behave as expected. It was brighter than predicted, larger than predicted, faster than predicted. And as new data came in, one question kept surfacing again and again. Why does this object look nothing like what we thought an interstellar visitor should be? Because if the models are wrong, then our understanding of how planetary systems form, evolve, and eject material into the galaxy may be wrong too. And that's where this story truly begins.
Before panic could spread, astronomers checked the numbers carefully. 3I Atlas is not a danger to Earth. At its closest approach, it will remain more than 1.5 astronomical units away, safely beyond the orbit of our planet. But safety does not mean insignificance. What makes 3I Atlas extraordinary is not where it goes, but how it moves. Its orbit is hyperbolic, with an eccentricity close to 6. To put that into perspective, a circular orbit has an eccentricity of 0. Anything above 1 is unbound, meaning the object will never return. An eccentricity of 6 is extreme even by interstellar standards. This object was not gently nudged out of its home system, it was violently expelled. And it is still carrying that momentum today. Right now, 3I Atlas is racing toward the inner solar system at roughly 58 kilometers per second. That makes it the fastest interstellar object ever observed entering our neighborhood. Oumuamua was fast, but only half as fast. Borisov was energetic, but still slower. Atlas is in a class of its own. Such speed immediately hints at a dramatic past. To reach velocities like this, the object likely experienced powerful gravitational interactions long before our solar system even existed, possibly with a giant planet, possibly with a binary star, or possibly during the chaotic early stages of galaxy formation itself. As astronomers refined the trajectory, another surprise emerged. On October 30th, 3I Atlas will pass just inside the orbit of Mars before swinging around the Sun and accelerating back into deep space, never to be seen again. But during that brief window, telescopes around the world have a rare opportunity to study something truly alien. And when they pointed their instruments toward it, they noticed something else that challenged expectations. This object wasn't inert. It wasn't a dry, tumbling rock like Oumuamua appeared to be. It showed signs of activity, a faint coma, a subtle tail, evidence that ice was sublimating as sunlight reached its surface. That alone placed it closer to a comet than an asteroid. But the activity was weaker than expected for an object of its size. This contradiction puzzled scientists. How can something so large be so restrained? Why does it glow so brightly, yet behave so quietly? To answer that, astronomers needed more than orbit calculations. They needed time-resolved data, and that meant watching the object spin.
Using telescopes designed to monitor transient events, astronomers tracked subtle changes in 3I Atlas's brightness over time. The goal was to determine whether it rotates, and if so, how fast. The results were unexpected. The object completes one rotation roughly every 29 hours. That's slow enough to suggest a stable structure, not a fragment barely holding itself together. But what truly surprised researchers was how little its brightness changed as it spun, only about 0.2 of a magnitude. That is remarkably flat. Oumuamua's dramatic brightness swings hinted at an elongated, possibly pancake-like shape. Atlas shows no such extremes. Either its shape is relatively uniform, or its coma is masking variations from the nucleus entirely. And then there's the size. Based on its brightness and assumed surface reflectivity, scientists estimate the nucleus of 3I Atlas could be around 10 kilometers across. That makes it vastly larger than Oumuamua and even bigger than Borisov. This is not a shard or a splinter. This is a substantial body, a survivor. As it approaches the Sun, more details are emerging. A faint dust tail stretches tens of thousands of kilometers behind it, shaped by solar radiation and the solar wind. Its surface appears deeply reddened, a signature of long-term exposure to cosmic rays in interstellar space. This red coloration matches what we would expect from an object that has traveled the galaxy for billions of years without the protection of a stellar magnetic field. And that brings us to perhaps the most unsettling possibility of all. Based on its velocity relative to the Sun, astronomers estimate that 3I Atlas could be between 3 and 11 billion years old. That would make it older than Earth, possibly older than the solar system itself. If that estimate is even close to correct, then this object formed around a star that may no longer exist. It could be carrying material from a planetary system that was destroyed, rearranged, or stripped apart in the ancient Milky Way. Unlike samples from asteroids or comets born alongside Earth, this object represents a completely different place in time, a physical record of conditions we cannot otherwise observe. But here's the twist. Objects like this are incredibly rare. Based on detection rates, scientists estimate there may be only one interstellar object of this size passing through a volume the size of Earth's orbit every 1,000 years. Which raises a disturbing question. Is 3I Atlas truly rare, or have we simply been blind until now?
The discovery of 3I/ATLS may be telling us less about the object itself and more about our limitations. Modern sky surveys have only recently become capable of scanning crowded regions near the galactic plane. For decades, those areas were avoided due to overwhelming starlight. ATLS didn't avoid them, and because of that, it may have revealed something we've been missing all along. Interstellar space might not be empty. It might be filled with relics of destroyed worlds, drifting silently between stars, waiting to be detected. 3I/ATLS is now giving scientists a final chance. As it passes through the inner solar system, every hour of observation matters. Measurements of its coma composition could reveal whether it formed in a carbon-rich environment or a colder, more distant stellar system. Continued monitoring may show changes in activity as it heats up, testing theories about why some interstellar objects are active while others are not. And once it swings past the Sun, it will accelerate outward, fading rapidly as it escapes forever. There will be no second pass, no return visit. Whatever we learn must be learned now. For observers on Earth, the comet will become visible to amateur telescopes later this year before disappearing behind the Sun. It will re-emerge briefly after perihelion, offering one last look before it vanishes into interstellar darkness. Tools like orbital trackers allow anyone to follow its path in real time, watching an object that has traveled for billions of years cross our cosmic neighborhood in mere months. This is not science fiction. There is no speculation about alien technology here, just hard data, careful measurements, and a growing realization that our solar system is not as isolated as we once believed. 3I/ATLS is a reminder that the galaxy is dynamic, violent, and interconnected. Worlds form, worlds break apart, and fragments wander for eons until, by chance, they pass close enough for us to notice. This object has beaten unimaginable odds to arrive here now during our brief moment of observation, and when it leaves, it will take its secrets with it, unless we're paying attention.